I have been using R and Python for a long time, but recently started to use Julia, and I really love it. The language is new. Unlike Python and R, which got developed in early 90s, the development of Julia started around 2010. So here is a short video on how to move seamlessly from R to Julia. Let me say a few words about how Julia is different from other programming languages like Python or R. At the end of it, all computers understand only one language, which is the language of zeros and ones. And that's how people used to program in the earlier days of computing. I was checking this video game. It's called Prince of Persia, and it was popular in early 1990s. I checked the development section and found that it was written entirely in assembly language, 6502 assembly. So that's the language of zeros and one or some equivalent version. The problem of using that language is coding is not easy, although it's very efficient because you are just talking to the computer in the language it understands. It's not efficient to develop big codes. So the computer scientists came up with a different method called compile language, and C, C++, Java, these are all compile languages. What they do is they take your code, which is written in an English-like form, and convert into the language of zeros and ones, and the process is called compilation. The method works well, except that the programs are not very interactive. You write a big program, you compile and run it, and then again change the code and run it. So a new kind of programming came, and it's called interpreted language. This is the one that you are quite familiar with when you use R or Python. So you write one line, R gives you the result, and then you write another line, and like that. The interpreted languages are really slow. So what Julia is doing is combining this interpreted method with compilation. What Julia will do to your code is it will run in some kind of interpreted form for the first time, but at the back of it, it will compile it. So the next time you run the same function, it's going to run the compiled version. Now, let me check what other advantages Julia has. I came across this thread in Reddit where somebody asked, I'm a new learner in the world of Julia. I'm yet to see its standout features and advantages over languages such as MATLAB and Python. So my question is, has there been any uncontested advantages or standout areas for Julia? So a number of excellent replies are here. I was checking this one. It's from 6 months back, so very recent. And this person says, I worked at a hedge fund. Our goal is to make money. Julia has made our research significantly more productive while saving us hundreds of thousands of dollars on AWS bill. I'll share this link at the bottom in the description, but I'll go over some of the main points. So the first point he's saying is that it's high level Python MATLAB like syntax, but the program runs 10x faster without any effort. And if you put some effort, you can optimize critical bits to 100x or 1000x. That's a huge advantage. The second point he meant is that uh, Julia has Lisp-like macros. I'll not go over much detail of macros in this video, but mainly what you do is you write code that generates code. So your code becomes much smaller, and that means your evaluation, your debugging, everything becomes easier. You have to check only 5 lines of code instead of 5,000 lines of code. Third point is Julia all the way down. Often when we write code in Python or R or other languages, we write some of the critical parts in C and then compile it. The advantage of that is those parts will run faster, but then you have to keep track of two languages. In Julia, you just have to know one language and everything can be done with just Julia. And that is a big advantage because the programmer doesn't need to keep switching between two languages, and it's good for his brain. Works with Jupyter Notebook. If you are from Python, you know Jupyter Notebook. So Julia just works fine with Jupyter Notebook. The next point is about concurrency. Julia uses the same parallelism concurrency model as GoSilk, which makes it easy to write single-threaded functions and then run them concurrently later. This is a big point because often we use multi-core computer. Every server these days have multiple cores. So you eventually want to run your code multi-threaded, but you don't want to spend a lot of time optimizing code right from the beginning. And then the last point he made was easy to profile allocations. And I'm not going into that detail, but the second comment was also very good. It says Julia codes are easy to run on GPUs. And it's the same point as these parallelism, that concurrency that was made here. You write the code and it automatically runs on GPU. So one thing he mentions is all broadcasting operations naturally turn into native GPU kernels. I'll talk about broadcasting in this video, so I thought this point would be quite helpful. All right, so I'll stop here. There are many other excellent posts, but you can see how Julia differs from Python and R. So let's take a look at the language. The first step in using Julia is to install the program, and I found that fairly easy. You have to go to this website called julialang.org, and they have a link download right on the top. And on this page, you will find installers for various languages. You have installer for Windows, for Mac OS, you have installer for Linux x86, Linux ARM, and then number of other installers. I used Windows installer and everything was straightforward. I didn't have to think much. Once your installation is done, you will get an icon on your desktop or your Finder if you are using Mac. Once you double click the icon, this Julia window will open. I'll show you a few simple commands which are similar to R. For example, if you want to add two numbers, you do 1 plus 3 and the result comes. And similarly, you can do multiplication, division, subtraction, all those standard symbols will work. If you want to do remainder, you use the percent operator just like R. So 34% 3 is 1. If you want to quit, instead of using Q, you have to do Control D. I'm not doing it here, but because the screen will automatically close. But you do Control D to quit. And if you want to clean the screen, you do Control L just like R. So I press Control L and I'm back to the top of the screen. Let's take a look at some other commands in Julia. If you do 3 greater than 2, you get true. If you give 3 less than 2, you get false. And if you want to check whether 3 equals 2, you do double equal. It's very similar to what you do in R. Another operation is power. You put 3 square, that's 9. 27. 3 to the power 3 is 27. So this caret operator shows you power. The first set of functions and operations will go back and forth to compare between R and Julia, our vectors. Let me first show you some of the commands in R. Then I'll go to Julia and show how they work. And in the process, describe the main differences. So in R, you can create a vector. Let's say you do x equals 1 to 10. If you do x, it gives you a vector from numbers 1 to 10. If you want a vector with 1, 1.01, 1.02, and things like that, then you do 1, comma 10, comma 0.01. And then your x becomes a long vector, 1, 1.01, 1.02, and like that. This is the SEQ vector. And the last thing I wanted to show you in R is how you can use a vector to do any kind of calculations, like let's say x times x. And that will multiply the numbers of this vector x with the corresponding number in x. So it's giving you x squared. Or you can do sine x. Or you can do plot x comma sine x. So you get a plot of the x versus sine x. Now let's go to Julia and see how to run the same commands. Let's learn about the vectors in Julia. There are some similarities, but there are also differences, and I'll show you both. If you want to create a vector with all numbers from 1 to 10, all integers, you do 1 to 10. So if you do x equals 1 to 10, that will have the vector x which has numbers from 1 to 10. If you don't want Julia to show it on the screen, put a semicolon. Now, how do you see all of the elements of x? If you type x, it shows 1 colon 10. That means it shows you the range, but sometimes you may want to see all of the numbers. If you type x dash, it will show you all members of x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The command for a vector going down is different in Julia from R. If you do x equals 10 to 1 and check the answer, it's 10 colon 9. So to get all numbers from 10 to 1, what you do is 10 minus 1 and 1. Because when you use the colon operator without putting this middle number, Julia assumes that you are trying to go in the higher direction. So you have to tell Julia that you are going in the decreasing direction by putting this number. And if you do x prime, it shows you 10, 9, 8, 7, 6, 5, all the way to 1. You can use the same syntax to create a vector similar to seq in R. So if you want to create a vector in R from say 1 to 10 with increments of 0.1, in R you do seq 1.1, 10. In Julia you do x equals 1.1, 10. Now if you do x prime, it will show you 1.1, 1.2, all the way to 10. And it puts this dot, dot, dot so that you don't have to see a whole bunch of numbers on the screen. I'll show you another way of creating a vector in Julia, and it's more similar to Python than R. What you do is type x equals range. You know the range command in Python. It's not in R, but you can use in Python. And then do 0, 10, and length 100. So it gives you a vector that goes from 0 to 10 and has 100 entries. If you do x dot, it shows you all the members of the vector. Now you are using length of 100. That's why these gaps are 0.10101. If you wanted to do 0.1, you had to put the length of 101. And now you get 0.1, 0.2, all the way to 10. Because Julia is using both the lower number and the higher number. So the length has to be 101 to get this uniform 0.1 gap. Next, I want to show you how to use a function on Julia vectors. You have two types of functions. The function sum, for example, will act on all members of a vector and add them up and convert that into a scalar or a single number. If you want to use that, my x is 0, 0.1 all the way to 10. If I do sum of x, Julia will give me the sum of all these numbers. But the other kind of operation is to do some function on every member of the vector. For example, if you want to do sine of x, in R, you do sine of x, it will convert every number or every member of a vector and do sine and return you a vector. If you want to do similar operation in Julia, you have to put a dot here. So you do sine dot x, and it creates a long vector with sine of all of these numbers. If you want to run piping in Julia, it's part of the core language. In R, you have to use something like tidyverse. In Julia, you don't have to. So here you do X sum, and it gives you the same result as sum of X. If you want to do piping with a vector operation and want to get a vector, for example, if you want to do sine of X, if you do X sine, and that will fail. It gives you an error. And why is that? Because remember, the sine operator, when you do sine of X, you have to put a dot. So in piping also you have to put a dot, and tell Julia that it's not just piping but dot piping. So you do X dot sine and you get the same result. This kind of operation with putting a dot is called broadcasting in Julia. So by broadcasting, what you mean is you have a vector and you are running a function on every member of the vector. This is called broadcasting. You will come across the term often in Julia. Finally, I want to show you how to draw a plot in Julia. In R, plots are part of the core language. In Julia, you have to import a package, and this will show you how to import packages too. So just like R, you have two steps. One is to install the package and another is to load the package. So to install the package, which is install.packages in R, here you do these two steps. You do import pkg and then pkg add plots. And then to use the package, which is in R, it's called library. Here it's called using plots. Now I already installed the package. It takes a few minutes to install the plots package. I already installed it. So I'm going to show you how to do the plot. I'll go switch to the Julia screen and show you how to plot. Okay, let's take a look at how to plot. You do using plots. I already have this installed. This will load the plots package and then I'll show you how to run the plots. Now that the plots is loaded, let's do y equals sine dot x. And I have two vectors, x and y. So the rest of the process is easy. I do plot x comma y. And Julia takes a few seconds to open a plot. It will open as a separate window. And it opened as a separate window, so I'll share that screen and you can take a look at the plot. So this is the plot I got, and it's the sine wave as you expected. Just like R, Julia also has data frames. And once again, you have to install the package, but with that, you can do very similar tasks as R. I usually prefer this data frame meta package because many of the dplyr commands can be done more easily with this data frames meta. So please take a look if you want to. I'll go over that in the next video. You will be able to see how to do all kinds of data wrangling.